guys, welcome back to A-Level Lessons. We're going to be looking at the next question today of your 2016 A-Level H2 Math Paper 1. I'm going to be doing question 6 on a bit of summation. Alright, so this question, part 1 is actually already out of the syllabus. So for those of you guys who are trying this 10-year series now and you are stuck on question 6 part 1, right, don't be afraid. This part is no longer part of the syllabus, take it out. Right, but the answer that they gave, okay, that basically that string, that line that we're supposed to prove, right, will come in handy later when it comes to the last part of this question. So just hold on to that part first, right? You don't need to do the first part, but it will definitely come in handy later on. So we're going to start off from part 2, whereby a sequence of u0, u1, u2 is given by u0 is equivalent to 2, and your equation is essentially when un is equivalent to un minus 1 plus n cubed plus n, and this is for n values that are more than or equals to 1. So how do we do this question? It's actually very simple. It's like a pattern-based question where you just need to actually substitute in the values of n. So they're asking us to find u1, u2, and u3. So u1 is very simple. Sub in when your n is equivalent to 1. So u1 is when n equals to 1, you get u0 plus 1 cubed plus 1. Apologize if you can hear like some knocking on the background, right? It's people doing construction where I'm staying. So this will give you a value of 4, right? Because u0 is actually just very simply 2. And then you have got u2, which is equivalent to u1 plus 2 cubed plus 2. And this will give you a total value of 14. Now that you have found what u1 is, which is equivalent to 4. And lastly, you have u3, which is just going to be u2 plus 3 cubed plus 3. And this will give you a value of 44. So this part, I'm just going to go through it very quickly because it's actually very simple. It's just simple substitution, and you'll be able to find the values of u1, u2, and u3 accordingly. Part 3, let's move on to part 3 now. Part 3 is looking at a methods of difference summation based question. So the question gives us, by considering this summation, which is from a value of r equals to 1 to n, and the equation that they gave is r minus 1. Find a formula for un in terms of n. So quite simple. This equation over here that you see actually looks quite similar to something that we have done before. Possibly not done yet. Okay, but essentially let's just see what this equation can be equivalent to. So this equation, if you realize, would actually give you the same answer, yeah, as essentially when your summation goes from r equals to 1 to n, and you have r cubed plus r, right? Reason being is when you look at the previous part, you look at part 2, right? Part 2 gave us that the equation is un equals to un minus 1 plus n cubed plus n. So what happens if we bring if you want to get it similar to this stage over here, you just need to bring the un minus 1 over. You get un minus 1 will give you n cubed plus n. So essentially, when we substitute this minus 1, we're essentially substituting out for n cubed plus n. But since we're using the value of r instead, we have to substitute in back the value of r. Okay, so that will be how we get this part on r cubed plus r. So the next step is, let's see what we can do, right? Let's try and maybe factorize it if we can, make it into a simpler form. So you still have the summation of when r equals to 1 to n, ur minus 1. This will give you a summation from r equals to 1 to n. But let's now take out the r, right? We can take out the r value, so we have got r times r squared plus 1. And now you notice that this looks actually very similar to something that we have in the first part of the question, which is going to be 1/4 n bracket n plus 1 bracket n squared plus n plus 2, right? Because that was the thing that the mathematical induction that we were supposed to prove. So that will be from the first part. So now we can start to do the question, right? So when we start off with a value of r equivalent to 1, we sub this into our first line where r equals to 1. So you have u1 minus u0. This would now be equivalent to, you can sub this entire thing out, right, to your first part of the question, equals to 1/4 n times n plus 1 bracket n squared plus n plus 2. So now this is where we just need to do very simply your normal methods of difference. So u1 minus u0. So now the next line we would have a case of u2 minus u1, and then u3. So we're just going to keep on adding 1 to our r value, minus u2 dot, and then we'll carry on with u. Okay, let's do the last line first, right? The last line is always easier. So the last line will always mimic, okay, the original equation, but now we have it with the n value because we are substituting for values of n. So you have un minus un minus 1, and over here you have un minus 1 minus un minus 2. So this is basically your normal methods of difference, right? We can cancel out all the similar terms. So you can cancel essentially this way, where you have it goes downwards this way, and you'll be left with un minus u0. So when we are left with that, you have un minus u0 would now be equivalent to 1/4 n times n plus 1 times n squared plus n plus 2. From here, it's actually very simple. They want us to find un in terms of n. So bring u0 to the other side. You have un is equivalent to 1/4 n times n plus 1 times n squared plus n plus 2, and plus u0. And u0, as we have already been given in the second part, is just 2. So therefore, okay, I'm sorry, I'm not sure if you saw any of that. Hopefully you did. I'll scroll it down over here. So un is equivalent to 2 plus 1/4 n multiplied by n plus 1 multiplied by n squared plus n plus 2. And that would be your final answer, okay, expressing un in terms of n. So this question was actually very simple. Okay, the reason why we knew that we needed to do methods of difference is very simply because of this minus sign over here. So every time when it comes to summation and you see a minus sign, you can already know that that is when you're going to start the method of difference. Once you have started it and it's equivalent to something, then you can go ahead and cancel out the common terms, and that should leave you with either 1 or 2 values that will either add up or subtract, and from there you can go on to solve what the question is asking for. So I would think this is actually a rather simple question on summation, your methods of difference. Part 2 was extremely easy. It should be a easy 2 marks in the back, and this would be roughly how you should be doing your summation based questions. Alright, so if you did learn something, you did enjoy this video, be sure to give it a like as well as to subscribe to the channel. It's free, it doesn't cost you anything, and it would really help me out a lot. Next few videos, we're going to be looking at the next question on a bit of, if I believe, complex numbers, and then we're going to move on to the rest of the paper and finish it up real soon. Alright, so if you have any questions, you can always leave it in the comment section like I've said. If not, I will see you guys in the next part. Have a good one. Bye bye.